Alright guys, sorry I couldn't be with you today. We are going to still take notes. This is 6.6 Systems of Inequalities. Your test yesterday, what we've been covering was just systems of equalities, where it was just equal signs and you had, the two lines that intersect maybe somewhere out here. This is going to look a lot like that. It's just instead of with an equal sign, we're going to be using our inequalities that are like the greater than or equal to, less than or equal to. That's what we're talking about today. So the first part is just the graphing. So we did this before where you just graphed one, but now we're graphing two. That's why it's a system. There's more than one. So for this first one, you just want to focus on this first line, or first equation. Y is greater than -2 plus 1. I'll give you a minute to copy that down, those two equations, and just make yourself a little chart. So this first equation, we want to start at the +1, that's our y-intercept. So start at 1 here. Our slope is -2, so we're going down 2 over 1, down 2 over 1, down 2 over 1. You could kind of keep this going this way. Whoops. Since this is greater than sign, do you want this to be solid or dotted? I mean, obviously I can't hear you because this is a video, but you want it to be dotted. There is no equal sign here. It should be dotted. And you've got to ask yourself if you should shade above the line or below the line. You could do the test point and test out 0, 0. If you did it that way, you would see that you plug in 0 for y and 0 for x, so 0 is greater than 0 plus 1. Well, that's not a true statement. 0 is not greater than 1. So we need to shade everything above it. This is where I'd really love to have you have colored pencils. So I'll make sure I leave those out for you. If you have colored pencils, you're going to shade up here above the graph. Actually, you guys it's better if you do this without colored pencils, because you'll need to do it with pencil on your test, and I need to show you what that's going to look like. So here's one. I'll show you with my colors just so that you have a visual of what I mean. That's my first line. I made it purple. It probably looks more black to you than anything. It is purple though. This line right here, we'll go ahead and graph this one. Y is less than or equal to x plus 3. We'll start at our y-intercept, which is 3. 1, 2, 3. Right here. I'm making it pink. And my slope is 1. So I'm going to go up 1 over 1, up 1 over 1. This is kind of my line here. And I want it to be solid because it's an equals. And I want to shade everything that's below that. It's less than, so I'm making this kind of like my house. So if this is the house, you're shading inside the house. You're shading underneath it. So everything here. Now, what's tricky about these is that if you have the line, you're like ignoring that there's anything going on with this. I'm shading this whole side here. So now I have like this side is, there's basically 4 regions. This side is like region 1, it's blank. This little region right here, there is no shading going on. This would be like region 2 where it's just purple. This over here is region 3. I'm just making the regions up. You don't have to know what they are. I'm just trying to give you a reference here. This is where, if you like kind of imagine this part right here, this is where it's pink and purple. They overlap. Region 4 over here is where it's just pink. The actual solution to this inequalities is this region right here where they overlap. So on your test, you'd need to like draw me an arrow or something or make this really super dark so that I know. That's why it's better for you to try this with pencil, because that's how you'll do it on your test. That this right here is the actual solution. This is the shaded region where both of those overlap. We're going to do some more examples, so I hope you're feeling somewhat comfortable. It'll be more comfortable once you get a hang of the graphing here. Sometimes they're going to be mean and give you equations like this. If you didn't copy it down, go ahead, try that out, write it down. You could graph this using intercepts. That would be one way to do it. It's probably easiest though if you just take this equation right here and resolve it for y. So I'm going to have my 3x minus y is greater than or equal to 2. Actually, I should do this in purple. That'll be my first one. 3x minus y is greater than or equal to 2. I should subtract 3y. I hope you're thinking about that. Careful when these cancel. I still have a negative y over here. That's important. Negative y is greater than or equal to negative 3x plus 2. To get y by itself, you need to divide by negative 1. When you divide by a negative, I hope you're remembering this, you got to switch the inequality. So this, you need to switch the sign. Switch sign. So this would be y is less than or equal to negative 3 over negative 1 is positive 3x. 2 over negative 1 is negative 2. So that's my first line. My second one, I'll do this one in pink. I'll write it off to the side here so we can solve them both. 3x minus y is less than negative 5. Should subtract 3x. So negative y is less than negative 3x minus 5. Divide by negative 1. Switch the sign again. You made it a greater than. This will be 3x plus 5 when you divide by the negative 1. So I switched the sign. Okay, now we're ready to graph. So I'm going to come back to my purple line and graph this one. Go down 2. I'm going to go up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. This line will be solid. And I want to shade underneath this line. So if you imagine this like a roof, shade underneath it. We're going all the way over here, shading this side. Then I'm going to graph this equation right here. Start at 5 this time. So 1, 2, 3, oh wait, 1, 2, 3, 4, 5. I can't really go up 3 over 3, but you can go down 3, left 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And I want to shade this greater than. So again, if you imagine this like your house, I want to shade above the house this time. So this time, this is a different example. On our first one over here, there were 4 different regions. This one actually only has 3 different regions because these lines are parallel, they're special. So this is region 1 where it's only pink, region 2 where it's white, and region 3 where it's purple. This region 2 right here, this means since nothing is overlapping, there is no overlap, this is actually no solution. Because nothing is overlapping. That means that there is no point on this graph, no point anywhere on here, that would satisfy both of these inequalities. No point would satisfy both of those inequalities. All right, I'm going to keep it rolling. I'm going to skip this middle example. I think you guys will kind of get the hang of this, although I'm not sure because I'm not getting any feedback from you, so I don't know. Sometimes you're going to have to graph some equations that look like this. They look weird. These are the compound inequalities. You kind of have to think of this as like if you broke this up into two statements. So this first one, I'll let you copy it down. -1 is less than or equal to x, which is less than 1. I'll let you copy the rest. This, we need to actually break this up into two statements. So this can be broken up into two statements. It can be -1 is less than or equal to x, and x is less than 1. It's like you're kind of covering up the one side, so it's like x is less than 1. Or if you cover up the other side, -1 is less than x. Okay, the problem is we don't like looking at inequalities like this. The variable needs to be on the left, so we gotta like kind of flip this around. So x is greater than or equal to -1. So you can just kind of ignore that. So x is greater than or equal to -1, and x is less than 1. If you were going to graph an equation that was an x, like x equals 1, that's going to be a vertical line through the point 1 right here. That's what I'm looking at with this one. X is less than 1. If I graph that, it would just be a vertical line. I'm making it dotted because it's just a less than. It doesn't have the equal sign. Just like that. We want it to be less than that. But hang on, we'll just wait a second. Then we should graph this one. X is -1. This will be a solid line. Again, it's vertical. There's some homework problems like this. So we want x to be greater than -1 and less than -1. You can also think of it like the between. X is in between 1 and -1. So that means we want this shaded part right here in the middle, in between those two lines. It's fine if you think of it like that. You won't have any ors, I don't think, to graph. There's just the ands, these compound inequalities. Okay. So if we look at the second one, y is between 4 and -3. If you look at this first part, it's like y is greater than, or I'm sorry, less than or equal to 4. So I could go up 4, 1, 2, 3, 4. I will make this a solid line because it's an equals. And I can go down to -3, 1, 2, 3. And that will be a dotted line. And y is in between these two. See how I shaded the whole thing? That's what you need to do. I'm expecting your graphs to look like this. On a test or quiz, I would expect it to look like this, where you're shading, you're like ignoring the yellow, pretending like it's not there for just a minute, and you're shading between the two blue lines. Okay, and the question though is, where are the blue and the yellow overlapping? And they overlap right in here. I should have gotten my green marker. This right here, point my arrow, this region is where it overlaps. Okay, you could just draw an arrow and that'd be fine. Or just make it super dark in the middle. You don't even have to draw the arrow. I just need to know that you know where the actual solution is. One more example, and then we're moving on to part 2. You guys are doing good. Hang in there. So right here would be another example. Again, we've got this x is in between -1 and 1. So here's my -1. Vertical line going through here. It's solid. 1 is a dotted line. And we want x's in between those two. So we're shading in between the two lines. Then I have this one now. Y is less than or equal to x plus 4. So I need to go up 4. 1, 2, 3, 4. My slope is up 1 over 1. This is solid. Maybe a solid line like this. And y is less than that, so you'd shade underneath it. Again, I'm ignoring my other lines. I'm just shading underneath the blue. And I need to see where these guys overlap. Where do the yellow and the blue overlap? Well, right in this region right here. That's where it overlaps. Whew. All right, that's part 1. Getting ready for part 2. These are story problems. You will have some like this on your homework and on your test, which will be next week, Wednesday. Don't worry about copying down every word here. Mostly you just need to draw yourself a little graph. You can say she works between 10 and 30 hours a week. She earns $6.50 an hour. She gets tips when she delivers pizzas. I'm giving you a minute to write that down. So first part, we need to write the system of inequalities. So she works between 10 and 30 hours per week. I'm just going to call what she works like X, the number of hours that she works. She works between 10 and 30 hours. I would accept it either way if you made it like with the little equal signs or if you didn't. It's not clear from the problem. I'm going to include it. And it says that she earns $6.50 per hour. That's a big deal. That's talking about slope. But she can earn tips when she delivers pizzas. Okay, we could write this as like the total amount that she's working. Like Y is going to be greater than or equal to 6.5x. Okay, this is because she's earning tips. We don't know how much money she's earning with the tips, so we just know that no matter what, she's going to make $6.50 per hour, 6.5x, and it's going to be more, whatever she earns is going to be more than that. This is what she earns for each of her wages, and then she'll get extra money with tips. So that's how we're getting the greater than. We're not using another letter for the tips or anything like that. It's just, this is just how it is. This is our system. We need to graph it. So over here we could graph it. So X is in between 10 and 30. So this coordinate plane is really not the best. We'll count by 10. So 10, 20, 30, 40, 25.50. That means my 10 and 30 needs to be up here between 10 and 30. This is just like what we did on the other side. And it's in between 10 and 30. I made them solid lines because they're equals. And this is really not going to be fun to graph. 6.5x. So I'm going up by tens here. Graphing works the same way. You could also make this tens. We would start at 0, 0, and then you'd go up 6.5 over 1. So up 1, 2, 3, 4, 5, 6.5 over 1. So this is a super steep graph. 1, 2, 3, 4, 5, 6 over 1. Okay. Not hugely concerned about how you're graphing this, mostly just that you're graphing it. And I want it to be greater than this. So I'm shading above the line. So if I kept extending these up, and if I would have made my graph big enough, there's going to be a little bit of overlapping region up here. So we just graphed them. Name one viable option. Well, she works between 10 and 30 hours a week. So she's got it, viable means possible, by the way. So she worked, I don't know, let's pick a number between 10 and 30. She worked 12 hours and earned, if she worked 12 hours, 12 times 6.5, I don't have my calculator, 12 times 6 is, wow, when you're not feeling good you can't do math. 12 times 6, can't even think, 72, right? Yeah, 72 plus 3, so I think it's 75. $75. It could be that she worked 12 hours and earned, she might have gotten a ton of tip money. She might have earned $100. We don't know. That's why we're graphing all the possibilities. This is just all the possibilities. So one viable option, they want you to list it to you as a point. So you could write 12 and 75. That works. It could be 12 and 100. Whatever. Something like that. And part D, I did not finish writing that problem. Josephina received $17.50 in tips and earned a total of $180 for the week. $180. It's probably how many hours did she work? You guys could solve that one, right? 180 minus her tip money. So 170, 160, 650. $166.50. So $166.50 divided by, she makes $6.50 a week or an hour. I need a calculator for that one. So she worked, it's not a very nice decimal, but it'd be, oh, that's why, because I couldn't do my math up here. This should have been $162.50. Probably most of you guys already knew that, and you're just laughing at me. It's okay. I can take it, especially because I can't hear you. Just kidding. All right, so, oh, not $25, 25 hours. 25 hours. This is actually one of the homework problems. I can't remember if I actually assigned it to you or not. If I did, wow, I just solved it for you. You're welcome. Make sure you know what's going on here. This one we're going to skip so you guys can get to some homework time. These are your homework problems. Same number as normal. I think there's 16. Maybe 17. Some of these are pretty easy. That's part of your exam review. That worksheet from yesterday, or those problems I asked you to do after the test, if you have them done, turn them in. I will be looking at those. If not, you'll probably need to talk to me. It's okay if you had questions or if it wasn't all the way done. You just need to turn them in, give them a try. I do want to go over them and talk about them when we come back on Monday. So I'll pass them back to you on Monday so we can talk about them. Hope the assembly was good. So you have the rest of the hour now to get started on homework problems. I'll see you guys on Monday.